So we're over here at UW, and we're talking to Susumu, who is working on some interesting voice projects here. So the one that you're going to show us today is a way to paint with your voice.
Yes.
Tell us about that. How did you start this project?
Sure, thanks. So this project is called Voice Draw, and it's actually an offshoot of a bigger project here at the University of Washington. It's called the Vocal Joystick Project, and that was started by a professor named Jeff Bilms and his other colleagues. He is from Electrical Engineering Department, and his students, John Malkin and Xiao Li, created the original recognition engine that was able to recognize these vowel sounds continuously. And the original application was to control a mouse pointer using your voice fluidly and smoothly. So just kind of give you an overview of what that's like. Basically, these are the sounds that the vocal joystick engine can recognize. And as you make a particular sound, for example, the as in cat sound,
Yes.
the mouse pointer starts moving up, and the louder you are, the faster it moves, the softer you are, the slower it moves. And you can smoothly transition from vowel sounds to change directions.
And then making no sound at all stops the cursor?
Exactly. So as soon as you stop vocalizing, the mouse cursor stops. And these what's called discrete sounds, such as k and ch, those consonant sounds, are used to issue different mouse actions, such as mouse click or toggling the mouse button down and up so you could drag objects around and so forth.
So the benefit to this, rather than doing up, down, left, or right.
Right. So there is already a way for someone to control a mouse pointer in some sense using the built-in Windows speech recognizer, but those tend to be much more discrete. So either you could use the feature called mouse grid, which brings up a 9-cell grid on the screen, and you keep subdividing and recursively selecting a region smaller and smaller.
Kind of a Blade Runner thing, zooming into a picture progressively, yeah.
That's right. And there's also a method
Probably not the best drawing tool.
Probably not. You just cannot steer it at all. There is a speech cursor method where you could say move right, move down, faster, slower. That tends to work, but it's restricted to 45-degree angles, directions.
And it's probably for the novice who's, they understand that a little bit better. How long does it take to learn to use this system?
So we did a longitudinal study, and we looked at 10 people using this for 10 sessions over 11 hours total. And about after the 5th session, people more or less memorized the whole mapping between the directions and the sounds.
So about 5 hours, and they were good with it.
Yeah, and I think that could vary depending on how they learn it. If they play a game and learn it that way, we think that it might actually cut down the time because of the engagement.
What other things have you tried besides painting?
So this drawing was one of the first applications aside from mouse pointer, but we've also explored trying to control a robotic arm, so a physical robotic arm with 6 degrees of freedom. We've also had one of my undergraduate students work on taking this into the physical world and driving this Lego Mindstorm robot that's kind of suspended on a whiteboard and controlling that with voice and various other things. Like we tried looking at combining a digital stylus input with voice, so it's almost like a multimodal or multi-hand input, bimanual input, except you're using your voice instead of a second hand, for example. And
you mentioned before that you did a little Flight Sim X.
Oh, right. So we also had a project called Voice Games where we tried to look at, can we take this to not just mouse, but also even keyboards or a combination of keyboard and mouse events and create something that you could use to play a game hands-free in a very fluid manner. So I was able to get flight simulators and simple games like Pac-Man, but we have a prototype version that also can control kind of a first-person shooter type game with all with voice. And
the voice joystick and this project, are they open source? Are they the types of things where someone can get the applications if they need it?
The vocal joystick project itself, the mouse control application is available for download online. You can go to www.vocaljoystick.org, and all the information, publications, downloads are there. Open source, we're trying to get into that process soon, but it's not currently yet open source.
Yeah, and people can contact you if they want more information
on it? Oh, sure, definitely, yes.
Can we see a demo of this?
Sure. I will just show you the voice draw program. Let me just go and clear this canvas first. Okay, so this app is something that I built specifically to be driven by voice and speech. So it actually combines both control through speech recognition as well as the continuous voice gestures that we just talked about. So I'm going to try to draw something real quick here. So now the Windows speech recognizer is running now, and here's all the commands that this voice draw application accepts. Let's see. Draw. So I don't know if you noticed, but the loudness actually is mapped to the thickness of the brush. So the slightly louder I am, the thicker it gets, and so forth. And in this case, the speed is fixed speed. So that tends to be easier for novice users who doesn't have quite as good of a control of loudness, so they could just focus on following a path.
And so the Windows speech recognizer is running. What do you have running in conjunction with that?
Right. So when we do this kind of continuous drawing, we switch from Windows recognizer, we turn that off temporarily, and then the vocal joystick engine becomes activated. And that's responsible for processing the audio input from the microphone, and every 10 milliseconds it generates basically output representing the probability of the different vowel sounds and so forth. And the vocal joystick library exposes that to the application, and the application could interpret it however it wants. In this case, the voice draw takes that, interprets it into 2D coordinates and thickness and so forth.
And we've got a painting here that you painted with this. How long did it take you to do this?
So that particular one took me 2.5 hours or so.
Not too bad.
So I should mention that in creating this project, I worked with a person who describes himself as an electronic voice painter, and his name is Philip Chavez, lived down in Berkeley. Unfortunately, he passed away a year after I worked with him, but he was one of the person that basically just gave me all the inspirations and the motivation to create a lot of these tools. And the artwork that he created is also available downstairs. But that particular artwork, he was inspired by Jackson Pollock. Oops.
Yeah.
And so he created his particular version using vocal joystick or the voice draw in about 3 hours, whereas it took him about almost 9 hours to create a comparable version using his previous method, which used to be Microsoft Paint and the speech cursor method I talked about, move mouse to the right, left, and so forth. So he used to actually create artwork using that method, taking anywhere from 40 to 200 hours per artwork.
What was the biggest challenge with doing this?
Creating this particular application, I think making it sort of intuitive enough that the user knows exactly what's going on, because especially for someone like Philip, who was used to using voice commands, this notion of using ahs and oohs to control something was new, and he was more used to just saying the commands. So letting him know that currently he is in this continuous sound mode, and he can't issue a command while you're in that mode, that was a little tricky. But once he got that, I think it didn't take long before he was very adept with the tool. So
where do you hope to see this go in the future?
I definitely hope that we could get this, especially the core engine of the library, available so more people can play with it and create new and interesting applications. There is a more practical tool that's based on this vocal joystick engine that's currently available, although I haven't actually made the link live yet. But it's called Voice Controller, and that basically integrates with the Windows Speech Recognizer, and you could use it to switch back and forth between the commanding and dictation features of the Windows Speech Recognizer and the continuous mouse control of the voice controller. And that should allow someone to do real actual work using just their voice without any mouse or keyboard. And so I hope to continue to enhance that as well. There's a couple of actual users out there who are using it.
So there's some people that you want to send some shout outs to that helped you with this project.
Well, for sure, yeah, definitely. First of all, my advisors, James and Jake, without their support, I couldn't have gone through this project. And again, all the people who helped make this happen, including the user study participants, and all the undergrads that helped make this possible as well. So there's many other projects that came as an offshoot of the vocal joystick project. So that involved a lot more people than myself. So I think if you go to the vocal joystick webpage, that should give you a pretty good idea of both the people involved and the different projects that came about.
Yeah.
Look forward to supporting them.
Well, great job on this. Thanks for showing it to us.
Thank you very much. Thank you.